All right, so it is possible to find the average rate of change for an interval between 2 points of a function by finding the slope between the points. Okay. Use the graph to find the y value for each x value, then find the average rate of change for each interval. So it's giving you the x values in the ordered pair, and we need to find the y values that go with it, and then we'll find the average rate of change, which is just the slope formula. So for here, I'm going to zoom in a little bit. Be helpful to be able to see a little better. All right, so when x is 2, y is 10, okay? And when x is 3, because again, it's giving you the x values, it's asking you to find the y values that go along with it. When x is 3, y is 9. So we're just going to enter those in. So again, when x was 2, y was 10. When x was 3, y was 9. So that was the first part. The rate of change between those points is, all right, so it's just finding slope. So the formula for slope is y2 minus y1 over x2 minus x1. First point's your x1 and your y1. The second point's your x2 and your y2. So it'd be 9 minus 10 over 3 minus 2. So you end up with 9 minus 10 is negative 1. 3 minus 2 is 1. That's negative 1. So let's enter that. Okay, that's good. Now it's asking us to do the same thing, just with 3 and 4. Well, we already know that the y value associated with an x value of 3 is 9. So that part's the same. When it's 4, the y value is 7. So let's just type those in. So 9 and 7. Huh. I guess I can't read. So you know what? That's in the wrong spot, right? It's not crossing at 7, it's crossing at 6. Okay. So see how that was crossed? I thought it was at 7. I just didn't. I looked at it too quick. Anyway, all right. So that's 6, not 7. Let's type that in. Change that 7 to a 6. All right, so just be careful when you're looking at the graph. That was an easy mistake that I just made. All right, so that looks good. I'm assuming it's going to now ask us for the rate of change between those. So again, just slope formula. So you got x1, 3, y1 is 9, x2 is 4, y2 is 6. So we're using that same slope formula. So 6 minus 9 over 4 minus 3. So you get negative 3 over 1, which is just negative 3. So let's type that in. All right, so that's good. Now it's asking us for between 4 and 5. So we already know the 4. The y value for 4 is 6. Now let's look at for 5. So I think it's all the way down here. So when the x value is 5, what's the y? It's 1. Okay, so again, when x is 4, y is 6. When x is 5, y is 1. Run that, that looks good. It's going to ask for the average rate of change between those. So again, we're just using slope. So it'd be 1 minus 6, same exact format, same exact formula. 5 minus 4. So you end up with negative 5 over 1, which is negative 5. So that's our answer there. Answer, that's good. Continue. All right, so now it's going to ask us a question about all that. Let's erase all that stuff. What is noticeable about the rate of change as the interval gets further away from the vertex? Well, what I'm noticing so the first interval was here, from the vertex 1 over, and then it just kept going 1 unit over for each interval. The rate of change became more negative. All right. So let's look at the answer choices. The rate of change decreases at a smaller rate. That's not true. It actually decreases at a larger rate. The rate of change does not change. Well, they're all different, so that's not true. The rate of change increases at a smaller rate. It doesn't increase. The rate of change increases at a greater rate. It does not increase, they're decreasing. And the rate of change decreases at a greater rate. That's going to be our answer because it gets more and more negative as you move further away from the vertex. So E is our answer there. One more question. Would the answer from part D change if the intervals were on the left side of the graph? Well, if the intervals were on the left side of the graph, the way that the question was asked was as it gets further away from the vertex. So it would be the same thing. If I was going to the left, the first interval would be slightly negative. The next interval would be a little more negative. And then the last interval would be even more negative. So it would still decrease at a greater rate. All right. So would they change? No. The change remains the same as the x value moves left from the vertex. Okay. Oh, okay. All right, so I'm just interpreting the way the question was asked differently. It says, yes, the rate of change increases as the value of x moves left from the vertex. So I was saying, no, it's not going to be different than the right side, but okay. I see how that's being worded now. So yes, the rate of change increases as the value of x moves from left from the vertex. So that's true. It changes the same way. So I guess that's why we're saying yes. Okay. That's it. Let me know if you have other questions.